Wait a second. So, is my screen visible?
Yes, sir.
Yes, sir.
Okay, so I'll now start with this. So first, I would like to thank Technical Club for um, presenting this uh, ML workshop. So I'll tell you all about the machine learning and how to get started with it, and what are the certain things that is required to start with it as well. So let's start. Uh, Let me first introduce myself. I'm Ambesh Shekhar, a researcher and engineer, and I used to be the secretary of TCC while it was founded. So next is we'll cover this whole thing, like what is AI and what are the things that happened throughout the time related to AI. Next, we will cover machine learning and what kind of machine learning there are and how do they work with examples. Next, we'll talk about how you can begin learning machine learning, understand fundamentals and everything, and like implement real-time projects, anything like that. Second, where to do. So there are times when some students found out that they don't know where to start. Like they know where to start, but don't know where to do things. So I'm going to discuss about that also. And in the last, I'll talk about what to do after everything is completed. Like you have understanding of ML and you have done some projects. Now what you have to do? So I'll talk about that in the last. So let's start with what is AI. So as the mm, as the Wikipedia defines, artificial intelligence is an intelligence demonstrated by machines, any intelligence that could be similar to human beings is called AI. That is presented by machine. So it's called AI. This is the Wikipedia definition. As from my point of view, it's more than that. Like there were times that a computer was only considered as simple machine that could do calculation at a faster speed. But the main thing that a computer lacked in its time was the AI. So it was inevitable to bring AI to the computer world. It was always needed, and like the computer was made exactly for artificial intelligence. Let's move on to the next slide. So this is the timeline of AI. So in 1943, wait a second. Okay. So in 1943, Warren McCullough and Walter Pitts proposed the threshold logic unit or linear threshold unit, now known as artificial neuron. Their research was helpful to move forward and have understanding of artificial neuron and how to manage them. Moving on to next, in 1950, Alan Turing proposed a method to distinguish between humans' intelligence and machine intelligence. He called it Turing test. In this method, we basically try to find out whether a machine can demonstrate human intelligence or not without knowing it. Next, so it was in 1966, we had our first chatbot called Eliza. This was developed by a German computer scientist and professor, Joseph Weisbaum. He developed Eliza with the aim to trick users by making them believe that they were having a conversation with a real human being. It was designed to imitate a therapist who could ask open-ended questions and even respond with follow-ups. Fun fact is that the term chatbot was coined in 1994, about 27 years later. Now, moving on to our first humanoid, which was developed in 1972, the Wabot WABOT1 was the first full-scale humanoid robot developed by Japanese at Wasabi University through the program started in 1967 to develop it. It was able to walk and communicate in Japanese, and it was also able to do all kind of stuff like navigating to different rooms and holding and moving objects. Later, researcher and engineers went to create Vabot 2 that could be capable of reading musical score and playing an electrical keyboard. So this was it all. Now next, moving on to nine. So it was 1966. Everyone said computers are great. Yeah, they can calculate, as I said, faster, but they cannot match human intelligence. IBM developed Deep Blue, a chess computer that took down Sir Gary Kasparov. He was the chess champion of their time. It was a big thing to happen, and now everybody knows computer are not just calculator; they are much more than that. So moving on to in 2006, we saw business boom. Like computers are available in a one-inch chip. So what's big? Business was thriving, so there were huge profits. AI just boomed the business everywhere, from your kitchen to MS Excel. We have AI to support everything. Automation became easier now. People can focus on developing new skills. Last, in 2012 and now in present also, we are seeing AI in healthcare now. They are diagnosing patients, recommending drugs, and exploring microscopic worlds. Recently, DeepMind, which is a team at Google, developed AlphaFold. That's an AI program to predict protein structure. So, if you could see, there's a gap between 1972 and 1997. It was called as AI winter. Many people say that, as there was no useful research or findings that could help to move forward in AI. So back propagation came into picture. It is a part of machine learning. As you could see, I've included that in machine learning. So the term was generally used in a work by Rumbot and Hinton and Williams, but they later on elaborated that and popularized it in upcoming time. So it became very popular. There were many times that the back propagation was defined in papers before 1986, but they were not much used. The algorithm was actually derived using dynamic programming capable of updating and fine tuning internal variables or parameters. So in 1987, Jan LeCun proposed an optimized version of this backpropagation algorithm, which is now being used in deep learning and now kind of nowadays of stuff. So let's move on to another thing that, so we can see that deep learning is actually a part of machine learning, whereas machine learning is a part of artificial intelligence. As I told you earlier, that definition of artificial intelligence, we also know that any technique that enables a computer to mimic human behavior, as you saw in 1966 chatbot. So, whereas machine learning, which is a part of artificial intelligence, it is a technique that give computers ability to learn without being explicitly programmed to do so. Like in previous time before machine learning, in artificial intelligence, it was like there was used to be if-else loop. Like there's someone a bot sees coming to give high five. The internal programs will run a code and they will get into an if loop and see that if the guy coming from front he is waving his hand, he'll probably bot will initialize the if loop and say let's do the high five. Whereas in machine learning there is no if else loop. It's mainly mathematics. So in the machine learning case, when a bot is watching someone giving high five, he doesn't do the if else loop. Instead, he tries to calculate the degree of freedom of the hand as well as posture, and based on all, then it calculates all the things, and based on that calculation, it tries to move its hand. If the value is 30 degree, so it will move its hand to 30 degree, and somehow it will end up to a high five. So that was something that machine learning was able to introduce in the AI. So machine learning was new phase in AI. Whereas deep learning is just a subset of machine learning, where it requires high computational resources. Like in machine learning, the computation is limited to very low, but in deep learning, it is gradually increased because the higher number of computation gives more better results. It was found in deep learning, and for that, it was the multi-layer neural networks was developed for this in deep learning. It was introduced. So let's start with machine learning. Before machine learning, let's buy something. Let mm, let's buy a phone. We want to buy a phone. That should be within a budget, okay? And like whenever we try to buy a phone, we consider certain factors like what the screen size and what other things are, camera and different kind of thing. So let's reduce that to only processor and camera and memory size. These will be the three factors which we'll be considering to like buy a phone. So we go to any commercial website and search for phones, and we get this all these kind of things, lots of phones and their specification, their price and their name. We get each identity. So now we have lots of option. We can buy anything. We can buy any one of them, but we want to like buy a budget phone and we need to have a good one. So we need to consider factors. So we create a table containing all its specification. What are the camera, what are the megapixels in camera, what is the processor speed, and what is the memory size, and also the price. So now we have to choose from this. So in machine learning world, this specification, this table is known as data set. So a data set is a collection of data providing meaningful information. So in machine learning world, it's like the model does not know what to do. He doesn't know what's megapixel is. He does not know what is processor. Does not know what is memory size and what is price. So we feed the model each data point, letting him know what's the difference between different camera pixel size and how does it affects their price. In this way, we give this whole data set to our model. So like let's say a newbie who don't know much about phone, and he but do know that if the quantity is good, high, so obviously that product will be great. So if we give this table to any newbie, he'll probably select a phone I would say he'll probably select this one, 13 MP, 5 MP, this one, that is in the fifth one. Most probably he'll select this one because it is low in range. It's okay, size is okay, 32 and 4 GB of RAM. It's MediaTek 2 gigahertz processor. I think that's the fast one over here. And 13 MP, 5 MP camera. He probably mostly like to buy this one, but what if this isn't enough? Like if he buys this one, how do you know that it's going to be a better phone? So, like many of the nerds know that MediaTek is not exactly a good one. Like here, you see that it's Q. It basically stands for Qualcomm, and MTK for MediaTek. So, if you ask any nerd, he'll say that Qualcomm is better than MediaTek. But how's going to machine learning know that? So, this thing that MediaTek is Qualcomm is better than MediaTek. This is known by a user. A user basically tells us that MediaTek works worst, bad as compared to Qualcomm. So we're going to add a new feature that is called rating, which is generated by user. So based on this rating, we can say that MediaTek works bad. As you can see, this 3.8, 2.7 rating. This rating is out of 5. Okay. So based on this, now someone who's going to buy a phone, he knows which phone he has to buy considering another factor called rating. So this thing that defines this is called features in machine learning in data set, whereas these rows are called data points. So we know that if we increase the features and also the data points, obviously the machine learning model will work great. So you can say that a data set is a kind of an elixir or power juice for a model. The more data set we have, the higher dimension, the more number of features and more number of data points we have, the more powerful the machine learning model could be. Because machine learning kind of works in the similar way that we do. We consider all factors and based on that we take decision. Same way machine learning works. It consider all factors and based on that it gives its best solution. So this is all. Next, we'll talk about types of machine learning. Okay, before moving on forward, does anyone have any question regarding my previous slides? Anyone? Are we good to go?
Yes, sir.
Come on, guys, reply, please. So we'll talk about types of machine learning. So basically, there are three types of machine learning methods: supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, we are given the data set and which contains X and Y. Let's say you must have learned about domain and range in your secondary school, that you have a input X and you try to throw it to a function and try to calculate Y. So it works in the same way. We have our data set and we have our features. So we have to find why. Like there's a price of a Intel processor. Like the seventh gen processor costs 40,000 and eighth generation processor costs 50,000. And similarly, eighth generation costs more higher and higher. So we try to give this feature, the seventh generation, eighth generation feature to a model, and we want to get an output that is similar to the y, that is the price of the processor. This is what supervised learning do. It trains the function, it trains the model to approximate a function so that any value x can if mapped to a function can result to y. That's the working of the supervised learning. So in supervised learning, there are two fundamental things that happen. That is classification and regression. Classification, which means you are labeling any class, labeling like dog, which kind of dog it is, which kind of cat it is. That is called classification. Whereas regression is calculating values, calculating the price of a product, car, anything. That's what in supervised learning. Whereas in unsupervised learning, we don't have any target y, we don't have any value y, like what we have to predict. Instead, we are given only features and we have to go through those features. The model has to go through those features and try to develop a pattern, like to find a pattern that could distinguish between different data points. That is what unsupervised learning do. So there are two things that happen, that is clustering and association. Clustering is same like finding in patterns, then grouping each data point to a cluster. They group each data point to a cluster. Next is reinforcement learning. So reinforcement learning is really a good thing. Like I would say it's really an AI thing. Like if you could see AI in action, then reinforcement learning is something that you could see daily. Like it's really a proper thing to say that reinforcement learning is AI. So in reinforcement learning, we have two things: an environment and an agent. Environment is just a world, virtual world, where we throw an agent and we try to make some rules for an agent. So like if he do any action, for any action we award him, or anything like we even punish him, that kind of thing we do with the agent in the environment. So here AI basically learns to act in the environment. He understands what to do, what not to do, and other things, which can be seen in a real human. A human also trains in a similar way. So I would say reinforcement learning is something that is much close to AI. Let's now learn supervised learning using an example. So here you see a gearbox system. Let's say that's a machine learning model, okay? And here is our data set where we have two features, two factors. that we have to consider x1 and x2, and we have to like find out why. So if someone knows, this table is actually an art color mixing chart. From I got this from color mixing chart, where we combine two colors to get this color y. So we give this x1 and x2 to our model, and that like processes it and gives a prediction. So now we have an error function that tries to find out how different our values are, the predicted value and the actual value. It calculates the error and try to find how much the actual solution is deviating from the predicted value. It then the value that we get from error, we pass that back to our supervised learning model. So what does the machine learning models do? It learns from the error and tries to change its variable, or fine tune its variable, or what should I say, optimize it, so that in the next time if it does any kind of prediction, it could show improvements. So we do this training. So we do this training again and again. We again feed the input, get an prediction, differentiate with the labels. We do this again and again until all the training data is not like training is not completed. Well, training means training on the whole data set. So this is what supervised learning is: training on all the data set. So finally, our model is trained. It has been fine-tuned, and all the parameters have been set from the features. Now we deploy them in a real world. We send this model to the public or to any company or to whoever the tester is. We give him this model and tell him to test this thing. So he give his random unseen data that was not in the training data set, and that's output something. So this output is the real thing. So this output that we got is what our machine learning model is trying to learn, to take input and provide this output. This is what supervised learning is. Moving on to unsupervised learning. So in this thing, you see that there's a machine with magnifying glass moving around. So this, let's say this machine is an unsupervised learning based machine learning model. So we don't have any y value target. So we don't know what we have to predict, but we have this data set, these rectangles and circles and triangles and colorful things. We have this our x, and we like just feed this to our model, and it tries to arrange them or group them or trying to form a cluster. So as you can see, it just formed three clusters, and these clusters are based on colors. That's the red cluster, that's the yellow cluster, and this is the green cluster. Here, unsupervised learning, machine learning model just group them based on this. So this is something that happens. But in case like we don't want to group them based on colors, we want something else as our output. So we tweak with our data set, or do some explicitly changes some parameter variables in the model. We can do that while coding. So if we do that, we can again form another clusters. And here, as you can see, this cluster is based on state. Similarly, we can try to get different kind of results if we change variables. Now, next one is reinforcement learning. As I said, there are two things: environment and an agent. So our agent has to interact with the environment. So let's say this environment is kind of a board with around 16 pieces, 16 time. There are 16 options which he can do. we Let's assume that he has to travel through each boxes and get to that green point. Let's say these yellow things are kind of rewards, like money. And whenever this agent walks on the red path, uh, he get hurt by any thug. Let's say a thug hurts him, so he has to get to a hospital. That is the green point. And for like every time he is hurt by a thug, he has to pay that much coin. Like if he has for whole travel he collected 2 coins, and he got hit by one. He got hit once, so he has to pay 1 penny to get diagnosed or heal up at that green point. So we make him travel from that yellow point to green point. Let's say, so we also give this agent a rule. The rule is that he has to get that to the green point with minimum distance and maximum reward and minimum getting hurt. Okay, so we make him travel. First he goes right forwards, I say, sorry, then he goes right, moving 3 times from the red spot, then he finally ends up at the green spot. So if you could see, he just earned 4 coins, but he got beaten 3 times, so now he has only 1 coin left. Another example, say we again make this agent to walk through the environment, and he go forward to the end. He get 2 coins and also get beaten up 2 times. Again, we he travels right. Now he has gotten beaten up by 2 times and now collected 1 gold. So he ends up here. Now you can see he has 3 gold coins and has been beaten up by 4 times. So he's kind of in a negative phase, like he still have a wound on him. So that's a bad thing. So again, the agent learns. He goes back to the starting point and again start making decision. This time he tries to make optimal decision. He goes forward and stop before the red point, and then it tries to move right. He got beaten up once, as you could see from the red spot. Next, he finally end up at the hospital. If you try to calculate, he now has 6 coin and has been beaten up once. So to say he's at profit. He has now 5 coin and like he has done the optimal thing. So in reinforcement learning, this is what an agent does. Tries to find out optimal solution for a given problem, and the problem is considered to be an environment. This is what reinforcement learning is. So this was all up to now what was machine learning. We will be moving to how to begin machine learning. So before moving forward, does anyone have any any questions regarding machine learning? Anything? Anyone? Any question about supervised learning? Anything? You can ask me, I'll answer it. Nothing? Okay, so we'll move forward. So how to begin? This is something I stumbled upon as machine learning was not exactly in our syllabus, though it was, but I wouldn't say it was a proper syllabus. But the main thing in machine learning is probability, as we are trying to predict the chances. What is the chance of this event happening? So that comes in probability. So we need to know what's probability, as well as we'll be working with data set. So we'll be doing computation on number of data points. For that, we need to use statistics, as we could explore more about data points and what are the factor R's, how they are interdependent, what is the correlation between them. So for that, we have statistics over here. But as well, so we'll be actually in the end, we are trying to make a machine learning model. To back them up, we will be using calculus and algebra, because all the computation, all the multiplication, addition, and all those things are majorly done by calculus and algebra. Statistics is basically to see data points. So in machine learning, the whole system is based on probability and statistics, but it is backed by calculus and algebra. So recently, I gone through your college syllabus and found out that in your first year you are being taught MA 103 and MA 107. That's mathematics 1 and 2. Many of you have gone through in your first year. So I gone through the syllabus and found that there was a module called matrices and advanced calculus. Advanced calculus much more. There were three modules on it. I have included all those three. If you go through the syllabus, you could find out. So this was something which was available in your syllabus, and also the books that were specified in your syllabus. Those were something I came across, and I think those are good things. Like those are the best you will be having during your college program. So I would say if you have to go through, if you have to start machine learning, you need to go through your coursework of your first year. You need to complete these things, and also 4 year series that must be in your second semester. 4 year series is easy. It's not easy. It's much more like a theorem that you need to like go through it and not like to learn it and everyday practice it. So this is something and applied probability also. So in machine learning, you need to go through these things, not much, not to get much deeper, and also these are not much complex because in 11 12 you have already learned a lot in calculus and algebra, as far as I remember, that are enough to back this up in college. So this will be something, and like if you are in second, third, or fourth year, I would recommend to go through your notes and like try to find out what are the things in that for your interview kind of things, because these are something that are fundamental and will help you to build your fundamentals in machine learning. Now, moving on to other things that are in CSE syllabus, I saw that was IT 401 and CS 473, which is statistics, ML, and deep learning. I think these two things are enough for you to like complete your fundamentals and basics of machine learning and deep learning. This is something which is only limited to CSE, but I think any other branches, EC or triple E, those who want to learn machine learning, they can like get help from their CSE friends that can give them books or like notes to these. That will probably help them. Okay, so that also another two courses that I found was pattern recognition and information and coding theory. So these two things are like advanced level. So to like get into these two courses, you need to actually complete the deep learning thing. Like what's the fundamental of deep learning, and you can now implement things using deep learning, any model, any deep learning model, natural language generation model, computer vision model, anything. After then you can go through these courses to learn about pattern recognition, but I think these two courses are not included in your coursework. It might or might not be. It's just that there are certain things at BIT that doesn't come in. So next thing is books. So in my time, like there were millions of books, hundred of books, and it was really a library. So if I have to go back and like recommend myself which books I should really go through, the for probability and statistics, I would really recommend the Probability and Statistical Inference by Robert Elliott and Zimmerman. That was a book that was as our textbook in second year. We were given this book to like complete our coursework. So apart from the coursework, it also contains a lot of things that was really necessary, and it defined probability and statistics elaborately. Everything was clear, as well as the exercise that they were in the book. They were enough to get your hands on what kind of probability, how does probability happens, what are the things that happen, random variables, and all kind of stuff. You can go through this book. This book is really good for beginners and also to understand. And like if you face any problem, you can go to your teacher, Rajneesh sir, and anything. He will really help you. Like I once called him and tried to ask what are the best books to learn probability, and he recommended me a whole list of books and told me how to start. So you can seek out help from your teachers as well for books. They will totally help you. Another book is for mathematics for machine learning. So this mathematics for machine learning includes all these four things: probability, statistics, calculus, and algebra. But I'm including this because of this calculus. So in machine learning, as a starting, the level of calculus that you need for machine learning is similar to your 11th, 12th standards integrals calculus. It's not there's not like there's not more than that you need to understand. Though in college, advanced calculus is something that's really great, but I think you will mostly need those things in case you want to do research activities, like into get into deep research. So that kind of advanced calculus will be needed those times. You don't need to like every day chant out all the integrals and learn about all the theorem there are in advanced calculus. Whenever you are going to start your research, you can just go through the book and try to find out what kind of calculus they are. Basically, you try to use calculus to like imagine how's your error propagating backwards, propagating back to your models. That's what calculus is really used for. Whereas in linear algebra, this is something like it is actually the system. It is developing the machine learning system. So for that, I would recommend Professor Gilbert Stein. He's a MIT professor who teaches linear algebra. He has two books, Introduction to Linear Algebra and Linear Algebra and its Application. These are two books that he has written, and like it's very clear. The book is very clear. You can go through these books to understand what is linear algebra, and you like be happy, like you just read a Bible or Gita. Really love it. So from now we have completed the books, but we can go through the books. Now moving on to video lectures. So there are times when students like they get bored from going through books and like those kind of stuff. So for that, I would recommend Coursera. First will be Coursera. So in Coursera, there's a course called Deep Learning Specialization. It is by Deep Learning AI and is taught by Andrew and G and his team. It's a great course to like for intermediate levels machine learners, engineers to start their deep learning course. They can to apply for this course. You can either buy, or I would recommend applying for a financial aid. You will get this course for free in 15 days. Or else, if you need this immediately, you can go onto the YouTube. There are videos for this also in free. You can go through this. Another thing is playlists. There are some selective playlists I've been gone through my whole year. One is MIT 1806 Linear Algebra by same Professor Gilbert Stein. As if you really go through his whole playlist, you'll find out that whatever he said in this whole video and whatever the questions he gave you, they are from the book, same book only. Whatever he's saying, like all the transcripts of this playlist are in those books. So I would recommend going through his video first. It's really great. He'll really make you imagine numbers. How does linear algebra work? How does numbers flow in linear algebra in equations? Another is Deep Learning by NPTEL, NOC, IIT Madras. This course contains Indian version of deep learning, and nothing bad to say, but Indian version of deep learning is something that no one can beat right now. So this course, this playlist, Deep Learning by NPTEL, NOC, IITM, I would highly recommend to go through this to like understand ML. The videos may be 20 to 40 minutes, but it is worth it. They are really great, and it will help you to brush up your fundamentals and basics of machine learning, as well as there are some questions which come in interview, like in research. Many professors ask this kind of questions from which come from this playlist only. Okay. So other are some channels that I have also gone through. One is StatQuest. Uh, this channel contains everything about statistics and machine learning algorithms. So in his video he do animation and all those stuffs to like make you understand what is going inside the machine learning model, what's inside the black box and everything. How does data flow and how does data work in machine learning world? Everything that happens from statistics point of view, frequencies by point of view, the StatQuest channel can let you go through it. Another thing is Three Blue One Brown. It is really a one thing that I would recommend go through. It's like the guy who's behind all these videos in this channel. He likes dream numbers. He dreams equations and numbers and know how to present this whole thing in his videos. He also make animated videos, but in his videos you could see how's everything working, like you'll see number as a kind of mechanism, any kind of gear, the flow of river and those kind of things. Numbers are flowing like a river, gradients are moving like a river. That can be seen in three blue one brown. It's a great channel, I would highly recommend for you for three blue one brown you have algebra and calculus also, so it will be worth it. Final channel is free code camp. So this channel is for those who want to learn technology. So free code camp provides bulk videos, like they provide 8 hours of video, 12 hours of video on lots of stuff. It could be math, it could be programming language like Python, Golang, C++, Java, JavaScript, anything. They provide videos on this, as well as they provide on courses like machine learning, deep learning, SQL, and other stuff. It's a whole bundle of all the technologies that are currently being used and are in use in for daily life. So you can go through the free code camp for this, for technology. Let's now move into what kind of technical knowledge do you need as a machine learning engineer, or like if you are moving into machine learning. So first thing is obvious, it's programming. You need to know what's a syntax is, how to write any syntax, what is data structure, what is algorithm. You don't need to get much into deeper in this algorithm thing, but I would recommend going through this, because at the end of the day you will be writing hundreds of lines of code, and you would prefer to write minimal codes possible and codes that could execute fast. So for that, I would recommend try to go through some DS algorithm. Okay, you can do practice from on portals, any hacker rank or those things. Another thing is object-oriented programming. So if you write like 10 line of codes, and you need to use that code again and again, I don't think so you will be writing that code again and again in other programs. You using object-oriented programming method, you can encapsulate that whole code into a class, and you can use that again and again in different environment, different ways, and like you can fine tune them and anything. Another thing for a data in this machine learning is Python. So right now, machine learning is enabled by Python. Python is the only language right now. There's other also, but right now Python is much more used in machine learning. It's possible in future other language could take over Python's place, but right now Python is the only thing that could that is necessary for understanding machine learning. So if you if you know DSN algorithm, everything, you can move to Python. It has lower number of data structures as compared to any C++. So it will be better to move into Python. Another is databases. So as I said, you will be working with data set. So how you are going to manage them? So for that, you need to understand what is SQL, what is databases, how you can manage any data set. For that, you need to learn SQL. So yeah, it's like if you're using SQL, you can manipulate the data. You can do any kind of visualization, any kind of accessing any data points. You can do transformation, aggregation, anything, any statistics thing. You can also do with Python using other libraries as provided in the programming language. But SQL is something that is asked by lots of people. Like in research areas, a professor like give you a server and they'll say get this data set from this server, and the whole system is based on SQL. So the only way you can get the data set is using SQL. As well as in private companies, they are project manager, product management, and though those are from business background, so they are not much into other programming language, though they have been taught SQL and Excel to understand data set and those things. So that's why SQL is important for any interview and anything like that. Another thing is package libraries and visualization tools. Sorry for the misspelling. So uh, packages and libraries are needed because Python is basically based on packages only. You can use anyone other classes, anyone other package, anyone libraries. So I think most of you have gone through the C++ or Java, any kind of language, and you have seen that we call out libraries like stdio or iostream. From that, we try to import printf, scanf, or C in, C out. So this is kind of similar with Python. So there are lots of packages inbuilt in Python, as well as you can also access other library and packages from GitHub. So there are lots of packages present on internet. You can access them and like call out them in Python to use them. They are necessary for your high level of use, since you can't exactly code everything and like you don't have knowledge or time to develop a whole code. So in that time you can make use of package and libraries. Last one is GitHub repositories. So in GitHub repositories, so wait a second. In GitHub repositories is really necessary as you will be writing codes and everything. So you need to create a like place where you're going to upload them. So GitHub is for that. And another thing is that in most places, people try to judge your experience and skills based on your GitHub only. They try to go through your GitHub page and look how much time you have spent on GitHub, how many times you have uploaded code and made changes and did other projects. They are going to GitHub and going to see. It's not like you have done months of project and you have saved them in the in your local system, and at the 30th of the day you are going to upload them all those files into the repository. That's not a good option. I wouldn't recommend that. So I would highly recommend to regularly update your GitHub repositories with anything. Like you are doing 100 days of coding, so upload your one code in the GitHub. Similarly, if you are doing projects, then update your GitHub regularly, make changes daily, and even if you are like want to change some documentation, you can do that also. That's now I'm going some particular things, that is programming. So as a starter, many people think where to start, where to like practice. Like you have learned all the programming, you do know what's DS and algorithm, and where you're going to practice. So you have options like Hacker Earth, HackerRank, CodeChef, Hackforce, code forces and those kind of stuff. So as a starter, if you're in first year and you just know how to write syntaxes, I would highly recommend HackerRank. You can complete, I'm not saying that to go or to do all the questions that's available on HackerRank. Do enough that so that you could have understanding, like you have covered most part of the programming stuff. Then you can move on to CodeChef or Hacker. So, like choosing what to do, like do you want to do Hacker Earth or CodeShare? This is a tricky thing. So, if you are like doing daily based exercise, like you have to do two questions a day, two coding questions a day, then I would recommend going through Hacker Earth. You can solve questions, two questions every day. And as for the Code Chef, there's a monthly challenge that happens. So it's good to like practice, but you also need to compete in activities in programming. So that could like make a platform for you. So I would recommend Code Chef competitions, monthly competitions that goes on, and try to participate in them. It's not like you have to complete all the questions. Even attempt one single questions in the competition, it's good enough. Finally, the lead code. So in fourth year, there are times when a certain candidate has been like got shortlisted by a big tech company, by Google, Microsoft, Adobe, and anything. So there are times like what to do now, like to continue Hacker Earth or like what to do, because these big tech companies, they don't exactly just take your understanding of machine learning, they also take your coding interviews. For that, you need to know what's coding and how to solve any coding problem. So for that, I would recommend LeetCode, as LeetCode contains database of previously asked questions by large tech companies, as well as lots of recruiters from big tech companies try to collect the same questions from LeetCode. They don't go Hacker, Code Forces, or CodeChef. They go to LeetCode to get the question, and they throw the same question to the to the one who are there interviewing. So I would recommend Lead Code. So there are times that Lead Code has a premium version. So for that, I would say like you need to decide whether not to take or take, because everything is free. But I would recommend take the Lead Code premium, like create a group and contribute equally and get a Lead Code premium, and like get this Lead Code premium of not of a month but of an year, and start working on this Lead Code questions a year before your particular interview that you are working for. That's all. So next thing is package libraries, and like as I said, in Python, you can't exactly develop every function, every code. You need to let have some support from other open source, and so there are packages like NumPy and Pandas. So in Python, as you know, you can't do faster processing. Python is very slower compared to C and C++, and like you have to do lots of computation, lots of multiplication and addition, because it's machine learning. You are doing basically all the arithmetic operations. So the NumPy comes into picture. The NumPy is useful in creating matrices and doing all the matrix computation, hamdas, multiplication, element-wise multiplication, dot product, anything. For that, NumPy is good. Whereas pandas is basically for statistics, to analyze the data set, how far is how much our data set is distributed, how well it is distributed, what are the outliers. For that, Panda is going to help you. Another thing is scikit-learn, also called as sklearn. So you know what's machine learning, you know what's linear regression and classification model, logistic regression. So you are going to write a code for that. But I think that will be like hard. Like there's a whole bunch of code, like about 2 pages of code to like implement that logistic regression, logistic classification model. So the sklearn comes into picture as it already have some machine learning model itself. So you can use the machine learning models that are present in sklearn. They are linear regression model, logistic classification model, multivariate regression, and random forest trees, and everything like that. And also there are some statistics, statistical functions like kurtosis, finding cosine similarity, and those kind of stuff. They are also available in sklearn. Whereas SciPy, it actually contains all the things. It contains all the statistics things, all the basically, if I have to say sklearn is basically encapsulating a part of SciPy to implement it machine learning models, all the work. Even in also that sklearn also have unsupervised learning models for clustering and association. You can go through that. So SciPy is basically being used by sklearn. Another thing is TensorFlow and PyTorch. These are deep learning things. So right now you have been working with matrices, but in deep learning you won't be working with just matrices. You will be working with high dimensional matrices. So by high dimensional, I mean that when you create a matrix like a square matrix, from my perspective, it's called two-dimensional matrix. But there are also three-dimensional, four-dimensional, five-dimensional, and those are called actually tensor. Those kind of matrices are called tensor. And to manage them, TensorFlow and PyTorch uses CUDA libraries to manage all those tensors, to compute everything. So you can use TensorFlow and PyTorch. Also, they similar to sklearn, they also contain machine deep learning models, neural networks, and how to implement them. Everything is inside them. You can go through them to understand. Finally, it's Matplotlib and Plotly. So these are visualization tools. As a like when you'll be going through the data set and you want to convey what's in the data set to others, you are going to do that with visualization. You're going to visualize histograms, scatter plots, pie chart, and for those there is Matplotlib and Plotly. Plotly is mostly used by business intelligence engineer or data analyst or data scientist, as it, yeah, it creates helpful dashboards. You can go through that. It's much deeper. So finally, it's our GitHub repositories. It's short one. So as I said, you need to save the code using Git. You need to learn how to use Git, because it's a way to like update your GitHub repositories. You can't exactly go to the website where the repository is and append the work. You need to know how to use Git. Git is a command line tool which is useful for GitHub repositories. Another thing is documentation. Whatever you are making, even it's 100 code challenge, even it's a like just a random thing you are trying to do, try to create a documentation, because whenever someone goes through your project, you will try to understand what is going on, and the best way to convey that thing is using documentation. Another thing is open source. So like I know that you all must be having projects and like you want to do your own project. So there are also open source, open end projects, like any other people is doing a project and it is a huge one, and you go through his project and you find there are some problems, like this 10 lines of code can be changed with one line of code. So you know that this could happen. So actually you send a message to the, like, create a PR pull request, or like talk to the one who's in charge of that GitHub repository and convey this message to him and try to tell him that I can do that. So that's called open source contribution. The one who's the main admin who's handling this repository will give you permission to, like, okay, you can do that, and also will instruct you to do what else. So that's called open source contribution. In nowadays, open source contribution is being very useful, as you are also getting hands on very big projects and getting involved in big projects, as well as many hiring managers and data scientists, when they go through your profile, they also try to see have you done ever open source or not. So if you do open source, that's a great thing. It will be like an internship, but kind of an unsupervised and unpaid, but still it will be worth it, I would say. So where to do? This is our last. So I think last day Raj sir must have told you about Collab, but there are also like Kaggle, Jupyter, and Collab and Database. So where you are going to get the data set, how you are going to information in the table format. So Kaggle provides data sets, like all kind of data set, textual data set, graphical data set, image data set, or just numerical data set in many forms: JPG form, JSON form, CSV form, Excel form. And they provide these data set, as well as they provide a platform, an environment where you can have access to 15 GB of GPUs, since deep learning requires GPU to calculate all the tensors and those kind of stuff. So Kaggle provides an environment where you can use 15 GB of GPUs for next 6 hours or 12 hours. I don't exactly know. Another is Collab, which is similar to Kaggle, though Collab does not provide any platform for your data set. It's much more like an environment, any ID, any online ID. You just open Collab and you have the ID uh, development environment, where you are going to write your code and try to implement deep learning models. You can upload your data set into the Collab using uploading methods. There are. Another is Jupyter, which is Jupyter. You can when you will install Python, when you will be installing packages, you can also install Jupyter Lab or Jupyter Notebook. So Jupyter is also a kind of IDE, a very friendly IDE for those who are beginners in Python as well as in data science or machine learning. It helps you to learn machine learning, as it provides a great environment. You can run code line by line in Jupyter. So last thing is Databricks. I wouldn't recommend Databricks to all, because it's much more centric to data engineering. When you will be having big data set, like 1 terabytes of data set, 1 terabyte size data set, then you will be needing Databricks, as it uses SQL, Spark SQL. There are lots of types of SQL, but all the SQLs are made from the basic SQL that you are going to learn in your coursework or on the internet. So Databricks is for developing machine learning models only in case you have a like big data set. So since you can't exactly 1 terabyte of data set, you can't load that into your RAM. Every time you are doing any computation, any variable is getting stored in your RAM, not in memory. So you can't exactly store 1 terabyte of your memory into a RAM. That's why Databricks come into picture. It uses Spark, Apache Spark to manage everything, data set. So this is the last. So like we know everything, we have covered the fundamentals, we know how to work on this machine learning, everything. So we have done everything. So what do we do now? So we need to choose a career path. As a starting your studying, you need to like create a name. What do you want to become? So there are many types of career paths. First is data analyst. So they come up with a solution quickly to help businesses in making time-sensitive decisions and have strong communication and analytical skills, passion for data visualization, and a drive for excellence and self-motivation. So what basically a data analyst do is it goes through the raw data set. There may be noise, there may be irregularities in the data set, and he kind of exploit them. He tried to find out meaningful information and he put forward these meaningful information in the team on which they are going to work, like in front of data scientists and scientists, engineers. They are going to use with the help of data analysts, they are going to use this data set. So this is the work of a data analyst. He goes through the data very subjectively, very concisely. Another is data engineer. So, sorry, a data engineer ensure uninterrupted flow of data between servers and application, and are also responsible for data architecture. So what they do is try to collect all the data. Since the data they are collecting, they will be giving that to the data analyst. But also they are not only just taking responsibility of collecting data, they are also like doing pre-data analysis thing, like cleaning. They also do the data cleaning thing. They clean the data because they will be handling large amounts of data. So they also need to know what they are working on. So they also play the part of their role by cleaning the data set and providing that to the team. Another is machine learning engineer. So machine learning engineer is the final output. It is the like they work on softwares, and their audience for this output consists of other software components that run autonomously with minimal human supervision. The decisions are made by machines and they affect how a product or service behave. So they are the end of the like project. They are going to finally develop the machine, the software, or that is enabled by AI. They are the one who are responsible for all the business activities for developing any software, any products. They are one who are managing all those things. Another is data scientist. So these people are like combination of all these data engineer, machine learning, data analyst, and all others. So these people are use their analytical and technical capabilities to extract meaningful insights from data for business. So they are the one and only reason was the business is booming. They are responsible. So they try to find out like even if the analyst is providing meaningful information, the data scientists try to think how this information is going to help the business, like what kind of new product that they could develop to get more investors or more shareholders, or like how do they popularize their models. So that's the responsibility of a data scientist, and it's kind of a big responsibility. So it's one of the role. Another is business intelligence engineer. It's like a junior data scientist kind of thing, junior data scientist kind of thing. He also do the same thing as a data scientist, but at a junior level. As he will be working as an associate for the data scientist, he'll be working as a sidekick. But his work is same as a data scientist, but it will be low level, and he will be supervise the main senior data scientist or lead data scientist. Another thing is AI scientists. So since there are lots of things happening in machine learning, so we need someone who will be doing the research, like moving forward this AI thing. So here, what AI scientist comes into picture? AI scientist or AI engineer, as what I am right now. So, data AI scientists are responsible for creating new ideas. They not only consider what these ideas will be helpful for the society or not, they also try to think how it's going to help them, like how it's going to, like the situation right in, how it could solve that. So they are continuously working on problems, trying to find out ways to solve them. So, what will be our roadmap? So, as you can see, this is your 4 years of college. So, if I recommend in your first year, try to complete your course, so your maths, everything, as well as all other subjects, and try to earn marks as much as possible. Because in certain companies, people ask for your marks, and they are like, yes, I'll definitely hire 8 pointer, or like consider very much. So they do say that we need high pointer students. When you will do that in first year, then you will have a sessional break. During this sessional break, try to learn something new. You can start your machine learning if you want to, or yeah, like do programming languages, or take competitions in those kind of thing, daily practice coding thing. Try to understand programming. In second year, you need to, like, if you are really into machine learning, and the machine learning course in third year, fourth year. So I would recommend to complete your basics of machine learning in your second year only, if possible, even the smallest level, which is enough to like practice on live data set. So try to practice your this basic thing, basic machine learning in your second year, and also start connecting with other peoples who are in this field, and that's in LinkedIn. Okay, so you'll be needing to connect on LinkedIn to peoples who are in this field. One thing also, that recently I have been receiving some LinkedIn requests from you all. So it's good. I would accept them. Actually, I have them. So the thing is that I don't find it is a good way. I would recommend that instead of just sending a connection request, you need to write an invitation, because it's show some generosity and also your communication skills, and how, like, how open you are. So like there are problem. I know that there are maybe introverts and ambiverts in our group who don't know how to start a talk. But I would say we know that you are juniors, you are newbies, and you will do mistake. So we are not going to take any action for that or not get offended. But we do recommend that whenever you try to give a connection request, at least add a few words like, "Hi sir, I have been in your workshop last day and it was great." You can add these kind of thing as it feels generous. So it's not like Facebook or Instagram. So I would recommend to do these kind of things in LinkedIn, because it show how professional you are. So after the second year, there will be another sessional break. So you will do the same, try to learn something new. So in last sessional break, you learned about programming language. This time you will learn an advanced, you can go to advanced level of machine learning or intermediate level of machine learning, and start working on beginners level project. So starts on beginners level project, like make mini projects. Any type of simple classifiers is enough. Even 10 lines of code of project is good enough for you. Add that to your repository and updating it, and keep updated to any technology. So in third year, you will be having your core studies, complete that, but also you need to do monthly projects now. As you are doing small projects in your sessional break, you need to do a bit level of higher projects in this third year, and like compete in various competitions, like there are Kaggle competitions, machine hack competition by AIM, and Coda Labs competition. These are competition I would recommend to go through. At least take part, and it's not like you have to complete the milestone. At least do something at those competition. Even go through the data set and try to find out meaningful information. That's also enough to do in the competition. You can do that. And also when you are in the third year, try to go through professors web page and get their mails and go through their works, and you can mail them to like do a research internship after your third year. That will be great. Or you can like connect to HRs on LinkedIn, or data scientists or researchers or anywhere, or in companies, and you can apply it through them. Also, there are companies who post data science internship programs, machine learning internship programs at LinkedIn. So you can like talk to the HRs who have posted those and try to ask, am I capable, am I enough for this role or not, for this intern role, or like ask the HR when there's be any internship program at this company. Like every year, Sony Research India opens about 8 position for data science intern. You can get selected for the role if you have a good resume, if you have done lots of projects, good enough project, meaningful projects, so you can get into that. And the companies like Grameener and 73 String, there are lots of, yeah, so just get updated and have an eye on them. So in your fourth year, let's say before fourth year, in the sessional break, let's say you didn't get the internship or anything, I would say take this as a 10% chance. I wouldn't recommend like totally depend on it, but if it's like 10% that this has happened, so try to do intermediate level project. Intermediate, like a very different, like try to find a novel approach. I would recommend that because it's really needed for your fourth year. So in fourth year, based on your last project in the sessional break, try to derive something else from it and try to pose that as your final year project. You will be needing to submit your final year project thesis. So I would recommend this. Or you can like extend your internship. In internship, you have been assigned a project, and you can showcase that at final year project submission time. You can also do that. So in this way, you can do that. Also, try to have eye on what kind of role do you want, and what kind of company do you want, and like an year or so, try to see when this particular role comes, at which year, at which date, or at which month does this role come in the market, and when to apply, and what are the responsibilities, because requirements will be the same every year. There will be slight changes, but that wouldn't affect much. I would recommend that. Another thing is that there are times that you will be biased, like you are not an IITian, or do not belong from CSE branch. For that, I would say, because IITians have really, like, they have their name, that it is written that they are from IIT. But you also have the chance, like whenever you will be taking competitions, obviously in those competition, an IIT will be also there. So if you like be up to their level or be above them, that will obviously will be a better thing. So in this way, you can be like favored by the project teams, by the teams, by the companies, even above the IITs. So that's something I would recommend. And as for EC, yes, I know that there are lots of people in EC who have applied for machine learning and those CSE kind of program, but they didn't get much because like CSE has really paid that much amount for their studies, and like they have given their post studies every day work in completing that. So don't feel bad. Instead, there will be small startups where you can start your work or like do internship. From that, you can give your profile to the main big companies, and if they want to consider, they will take you in, even if you are from non-CSE branches. So that's all. Thank you. So, do you have any questions? Anyone? That's all for me now. Guys, are you there?
Yes, so
So this was all. Uh, okay. So anyone have any questions? I know this may have gone lengthy, I've talked a lot about how to get started in ML, but this was something that's really needed. Machine learning, as myself, I have gone through some problems while starting machine learning. So, anyone have any questions?
Yes, so we have received few questions in the form responses. The first one is from Samar Pratap. He's asking, what are the disadvantages of machine learning?
So, like disadvantages of machine learning. So, if I have to tell you, right now, the machine learning is like backed by an algorithm called backpropagation, as I've told you earlier. So, it has limits, like it exactly can't update it. There are times when you have a data point and the machine learning model cannot approximate that. So these are kind of problems you can get into, as well as um, I think this is the only thing we are facing it right now. There are alternative methods for backpropagation. Many researchers are working on. This is something that's right now we are facing in machine learning. Backpropagation. We can't exactly truthfully approximate that. We can't exactly get that data point we want, as I shown in supervised learning. We can't get exact value. That's something. That's some problem we are having in machine learning. Any other question?
Yes, so one we have from Prateek. He has asked, how is AI becoming useful for people with special needs like autistic adults or children?
What?
The question he has asked is, how has AI been helpful for the people with special needs like autistic adults or children?
Okay. How should I say? So, like right now, there have been development in. Should I say this? There have been development in healthcare systems. Okay, so like for old peoples, we are working on uh, developing drugs or immunology, whereas for children's, we have now cutting edge technology to monitor children's and uh, we have technology to monitor. How should we have technology to monitor children's behavior and how what are the problems they have been going through. So machine learning is kind of monitoring those kind of stuffs and trying to develop means recently, as you know, the concept of chatbot. Recently, I worked on a paper where you can consult a machine learning algorithm to give you a response what kind of things you should do to have a better immunology and health, any those kind of things. So in this way, I think old peoples and children's can be helped by ML. Okay, Abhinav, you have raised your hand, I think so.
Yes, sir. I have a question. Like, for example, I want to make a machine learning model. For that, I will need some data points, as you said. So, how do I collect that amount of data?
Okay, so first thing is that Kaggle already has a repository for that. You can get access to dataset. There are lots of dataset. There are lots of varieties in it. Apart from that, there are times like there's a website and you want to get dataset from those particular website. For that, you can use Scraper. So Scraper are some kind of it's a kind of automation system. Like when you initialize a scraper on a particular web page, you can extract all the things that you want from the web page. You can program a scraper to scrape a particular thing from a web page. In these kind of way, you can get the data set. Another method is by doing surveys like Coda Lab competitions. There are times when Coda Lab conduct a survey where they collect the data. So in those ways, you can also collect the data. And also there are websites like CDC where you can get microscopic images by scraping. So these are some methods we can you can get the data set. But as an initial, like you are starting, I would recommend Kaggle for that. Any other questions? Anyone? Okay.
If anyone has any questions, they can write in the chat box as well. Or if we are done with the questions, I would like to hand over to Abhinav sir for vote of thanks.
Stop presenting. Okay, Shubham Kumar, you have raised your hand.
Sir, can you tell us more about the Google Collab platform?
So,
How to use it and how
so
it will be
have
beneficial
you
for us?
used Jupyter Notebook? Have you ever used
No,
Jupyter
sir.
Notebook? Okay,
So I have
so
a spider, sir.
that means you have the understanding of Python.
Yes, sir.
So let me give you a live thing. Okay.
Okay, sir.
So this is the main website for their collab research google.com. You can like create a new notebook. It will create a new ID, new environment, new file that will be saved in your accounts drive, whichever account you have been signed into. And like this is the code. So we connect to a machine that's available on in Google at Google. The Google gives us a machine, any CPU, it can be CPU or GPU. So here you can do all the Python programming. So like we have to store a value 10 in the variable p. We can do that. We just wrote down the code and p. If you see, try to print this value, we have stored 10. So what does this do is we can do line by line programming. So when you used to study C, C++, you have to write the whole code and do compiling, then you have to run. In Python, it's different. You don't need to compile or anything. It just runs by running this. You have to run this, and like you have this value has been stored. Similarly, you can define a function over here or class, anything like that, a plus b, and it will do the thing. Similarly, any class you can do. This is something, but the main thing over here is how you can best use. So, as I told earlier, you will be needing GPUs for your deep learning thing. So, Google gives you option to use GPU. In none, you are basically using a CPU with no GPUs. When you switch to GPU, now you are using NVIDIA's GPU provided by Google. If you want to know much more about what kind of GPU you are using, you can try this command. It will give you like the GPU that we are using. It is called Tesla T4, and the amount, how much GPU there is. So here you can see it's approx 15 GB. 15 GB of GPU you have been allotted to do your deep learning works. So in this way you can use Collab. If you are using none, you using just CPU, you can do your you can learn Python over here, or you can conduct your research over here, or any project you want to. So this is a good way you can have access to a bigger GPU. As you know, in computer you have only 2 to 4 GB of GPUs. So do you understand anything?
Yes, sir. Thank you, sir.
Okay. Anything else?
So I think that we are done with the questions, and I would like to end the meeting. So,
Yes.
sir, very, very thank you for coming up here and speaking on getting started with machine learning and showing that a detailed PPT, like you worked really hard and made it descriptive, and those animations were really helpful to get a clear picture. I think that this will encourage some students to start their projects or their careers in machine learning. And special thanks to our audience for being the part of this session. And at last, I would like to say all the best to you, sir, for